So you have the graph of f prime of x on the top right. If I had been really careful with this, I would have said that f of x was defined from -4 to, it looks like 6, and then f prime of x is, of course, defined on the open interval from -4 to 6. So it's important that it's the original function is defined so you know what's going on, but we're really just talking about the endpoints there because if the first derivative has a point, then the original function must have had a point. So what we're going to do is actually just identify different attributes of the original function using this graph, which is the graph of the first derivative, which you have done in the past because you have had the graph of velocity and had to identify things about the position. So this is the same thing, but without a context. So it's a little more abstract, which is why I started with the context when I taught this, because this is a little tougher for some people to kind of grasp. So the first question says, what are the critical numbers of f of x? Now, what you just learned was that critical numbers were critically important to the shape of the graph. They're where something happened. So to find them, it was when the first derivative was 0 or undefined, but the original function was defined. All right, and we're not talking about endpoints here, just FYI. So if I look at this graph where the first derivative is 0, that happens here, here, and here. So I have 3 different critical numbers. So I would say x equals -1, 1, and 3. Then if I wanted to justify this, I could say f prime of -1 equals 0, f prime of 1 equals 0, and f prime of 3 equals 0. It's actually very rare for you to have to justify that, but I thought I would show you one there. So the next question is, on what intervals is f of x increasing? Well, this is the slope of f of x. So if f of x is increasing, the slope is positive. So I would say f prime of x is greater than 0, or f prime of x is positive. So I'm looking for the intervals where the graph of f prime, which is what I have, is above the axis. So if I'm looking at this graph here, then it happens here and here, above. F prime of x is above. So that is from -4 to -1, and from, it looks like, 3 to 6. On what intervals is f of x decreasing? Well, that would be when f prime of x is less than 0. If my original graph is decreasing, the slope is negative. So that would be where I'm below. So I'm going to say from -1 to 1. We'll talk about why I'm splitting this up in a minute, and from 1 to 3. Okay, so if you had gone from -1 to 3, you would be okay if you changed your justification in this case for f prime of x is less than or equal to 0, but you've got to be very careful about that because now you're starting to mess with endpoints. And you have to figure out what is the context of the situation you're using. If you do it the way I did it, you are fine 100% of the time. So I avoided where f prime was actually equal to 0, which is where the graph flattens out. And I just stuck to where the graph was actually going down from left to right. So f prime of x less than 0.